Now, you've got my rainbow of a diagram here. I really, really hope you drew a diagram because, good Lord, that's a lot of geometry that's interacting with itself. And you have to put some constructions on there and all that kind of thing. Now, I sort of hoped you would go okay on this because we proved this exact result. It has a name. Does anyone remember? This is the satellite dish. Thank you. This is called, you can see in here, you see the angles that I've marked, right? So this is the reflective property of a parabola. It's what means that for a satellite dish, all the radiation coming down, it reflects up to the focus, or for a set of headlights on a car, one light all goes in random different directions, but it all goes forward, or in this case, upward. Okay, so we have proved this actual property before, but it was a while ago. So I certainly can't actually remember all of the individual steps, but at least I knew I was getting at. Okay, so I won't labor all of the individual lines here. I will show this back to you when we're done. But let's just go through the major themes. So explain why SP equals PD. See that word explain, right? So I'm expecting some kind of reasoning from you. It's only 1 mark, so it doesn't have to be an essay. That's all you really need to say. Okay, what are we assessing here? Do you understand what a parabola is and what its relationship is with the focus and the directrix? That's all we're looking for. Okay. Once you state that, part 2, that's also kind of a gimme. We've worked with this equation before. It's pretty easy to find because they say show that and there's a mark there. We expect you to actually find what that derivative is. Not that it's difficult. And then sub it into point gradient form. So that's not complicated. Okay. Right, part 3 is where stuff starts to get a little more fun. It's still not complicated though, because you have to prove that PQ is perpendicular to SD. Just let me hide my working for a second. You've just got to orient yourself properly, right? Look at where PQ is. You know what its gradient is. Look at where SD is. Well, you don't know its gradient, so you have to find it. Okay, so you can see what you're doing, and that's why you can see I go straight to finding the gradient of SD. Okay, quick question. This set of coordinates here, where did that come from? It just, in my answer, it just seems to come from thin air. Where does it come from? Yeah, Eric.
R and the directrix.
Okay, fantastic. So you can see that, wait, hold on. Do you mean P? P, yeah. So D, have a look at your diagram. D is vertically below P. So that means they share an X coordinate, yeah? How do I get its Y coordinate? It's on the directrix, and everywhere on the directrix, Y equals negative A. So that's where that comes from. You can pump it into your gradient formula, and then out you get it, okay? Have a look at this. Please don't worry about writing all of this down, but I would encourage you to read it along with your diagram, actually. I haven't introduced any letters. I've just used the letters that they've got. So you've got to do some angle sums. You have to take advantage of an isosceles triangle. Which isosceles triangle is it? Have a look. PSD. You know, that one that in part 1, you proved that the sides are equal. You were the one who proved that they're isosceles. So we didn't just throw that in for fun. We threw it in to give you a clue. Okay? You've got to use that isosceles triangle. You've got to do angle sum of triangle again. And then you find that, I just called it theta so I didn't have to keep on writing the letters. Okay? But you didn't have to do that. So again, I'll send that through to you when you're done. And I asked you to skip 5 and 6 because for time, just so you actually had a reasonable amount for that. Any questions about that proof for the reflective property? All right, yeah, Russell.
You could have done 5 and 6, right?
Yes, you could. Yeah, I just did it for the sake of time because I knew you were running out and I ran out anyway. Okay, how are we faring? All right, so we are currently on to question 3. I only wanted you to do one last question in this one, part E. Okay, now I'll admit this question has a bit of a rude trick in it, partly because you can see it's in a topic like, look at the question 3, it's all about polynomials. I asked you to skip most of this question because we know polynomials, you actually know enough to do all these questions, but they're not going to be assessed in Wednesday's task. However, I chose to leave this one in here because most of it doesn't require like all the fancy polynomial stuff you've learned so far, just a little bit, okay? So you had to find the equation of the tangent to this curve at that point. What's going on? It's a cubic, right? So x cubed minus x, you can actually know exactly what this, I'll leave this color. You can know exactly what this looks like, right? Can you help me factorize this thing? What is it? X, take it out, you get left with that. And then you can factorize again, right? What do you get left with? X minus 1, x plus 1, you get difference of squares. So this is a very simple cubic graph to draw. I'll just leave it there. You're going to get 1, 2, 3 intercepts. So, oh, I missed, but you get the idea. Okay. So this is what you're getting. And then they say, hey, I have a tangent at some point, and it's going to intersect the graph somewhere else, like here and here. So what's the something else? That's the question. Okay. So what did I do? Well, you can see that I had to find the equation of the curve first, of the tangent, I should say. You need a point, which has been provided. You also need a gradient. So you can see what I've done. I had to differentiate, wasn't complicated. And then here is your point gradient, form. Are you okay with that? So I know it looks like algebraic soup, but it's just substitution into a simple formula, okay? I'll admit it looks like a bit of a dog's breakfast there, but I just have to have a little faith that it's going to pan out, okay? Does anyone have any questions up to that point? Okay, now, just like we saw with Paul earlier, when you want to find points of intersection, what do? Between two curves, what do? You have to solve simultaneously, don't you? Okay, so I've got this curve here, and I've got the original one, which gives you this. And you look at that, and I guess this is what Russell was talking about when he said, oh, I just looked at this paper and it was fun to begin with, and then I see him doing the rest of it, because you just look and you think, I don't want to do this. Now, this is where the trick comes in. And maybe you won't encounter a question like this in your tests on Wednesday, but there's a good chance in the future you will. Okay, just have a look at this note I've jotted down on the right-hand side. This is a cubic, and we're not really used to dealing with cubic polynomials, right? We will get more comfortable with them, but we're really just at the start. So we're kind of babies when it comes to this. Quadratics we're really good at handling, okay? But you probably got to maybe this point, and then you were like, what do I do? There's no quadratic formula for this guy. There's a cubic formula, but it's disastrous. You don't even know about it. So you need to take advantage of something you know from polynomials. X equals t is a solution, right? We got the question itself tells us that because there's a point of intersection. That means that x minus t is a factor. Can I say that again? If x equals t is a solution, or a zero might be a better way to say it in this context, then x minus t will be a factor, okay? Now, at that point, because you guys know polynomial division, you could have gone straight for it. You could divide the cubic polynomial by x minus t, and you'll get the answer that I'm going to get down here. But I chose to do this without it, just to demonstrate to you, yeah, you don't need to know how to do polynomial division if you've got a rough idea of what factors you'll expect, okay? So what I did was something you might remember from quadratics, when you're factorizing non-monic quadratics. Remember you got that middle term and you split it into pieces and then you pair things up. And that's exactly what pans out here. I know what direction I'm heading in because I know what factor I'm expecting at the end. This guy over here, okay? So once you do that, it actually falls out quite simply. I know it looks long, but it doesn't take a lot of thought. It just takes some patience, okay? Once you get that, you factorize, 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 and then you come down to here. Now, when you look at this, you're like, oh, there's two solutions, right? But you already know one of them, the x equals t solution, which comes from here. So that's why you must say the other solution comes from here. Does that make sense? Okay, so after that, you sub it in and you're fine.